Well, pre-calculus classes, one final time. Good morning, good afternoon, or good evening. We're going to actually wrap up the last set of notes, and it's probably a little bit shorter than some of them here with the last part of section 10.5. It's just a little bit long to where we don't actually have that all in one single set of notes. And basically what we're going to do with this last part is let you see how if you are asked for just one of the terms, or even maybe just even the coefficient of a single term from a binomial expansion, how that works. And so, we're going to actually come back and use one thing from the day one notes, and this is where now this whole combinations and factorial component of things actually is going to work. So, in, for example, 5, for instance, I realize, yes, we've already found this, but if we just wanted you to find this single term of, 2x plus 3 to the 4th, if we wanted you to find the coefficient a in the x to the 3rd term, well, what you're going to do is the coefficient, that's where we use this n and r combination. And so what you end up doing is, if they want you to find, so the 4 is always the n, so we're going to do 4 and then whichever power they want here. 4 minus 3, we'll use 4c1, and so that's what that is. And then all you're going to do from there is take, since we want the x to the 3rd, you're going to take 2x to the 3rd and then 3 to the 1st. These two powers will always add up to the 4th. And then again, so basically whatever power you're using for the non-variable term is what'll go there. 4 minus 1 is 3. And so from here, what you can do is when you enter in that 4, C1, well, it's just 4. Now, for one like this, where we're just actually asking you for one of the terms out of the 4th row expansion, that's where it's almost just as easy to, do the entire expansion and not have to worry about it. But that's, so then it's 8x to the 3rd times 3, or 4 times 8 is 32, times 3 is 96x to the 3rd, which matches what we did the other day. So that's kind of letting you see how this works with one of the ones we've already done. Now, a little bit higher order one, x plus 3 to the 12th, the coefficient of the x to the 5th term. Well, again, what's going to end up happening here? 12, and then whatever the power of x is going to come from, we're going to take 12 minus 5, so this bottom number is 7. And then we're going to take x to the 5th and 3 to the 7th. Now, from here again, kind of how you go about doing this, we'll kind of leave that up to you as to just how specific you want things. But we're going to do 12c7. So again, enter in the 12, then, so that is 792. X to the 5th, and then 3 to the 7th is 2,187. And now we can just multiply those together, and that's going to be a very big number. 1,732,104 x to the 5th. So you can see we would not actually ask you to expand x plus 3 to the 12th. I mean, that'd be 13 terms, and some of the numbers get pretty ugly because when you're taking 3 to a power along with some fairly high order combinations, again, those numbers get pretty big. All right, if we happen to have one with two variables, how this one works a little different, where we have 2x plus 3y to the fifth. Well, again, what we have here is we're going to use a combination. 5 is the top number. This is, since it's x to the third, again, we want 5 minus 2 is x to the third. And then it's going to be times 2x, since we went to the third power, 3y to the second. And so from here, 5c2 is 10. 2x to the third is 8. X to the third, 3y to the second is 9y to the second. And then, 10 times 8 is 80. 80 times 9 is 720. X to the third, y to the second. And I guess technically with all of these questions, all they've really wanted, 96, the 1,732,104, or the 720 is our answer there. Again, on a test or quiz, if you're writing out the entire term, that's fine, but really all you need truly is the coefficient. All right, one last thing that has not come up yet. Let's say we wanted you to take x squared plus 2 to the sixth. Now, here's one thing that you do have to kind of watch as well. So we are still going to use a combination, 6. Now, this is where you do have to be a little careful. They want the x to the fourth term. Well, keep in mind, we're starting out with x squared. So in order to get an x to the fourth term, that means this is squared, and then we're going to be taking 2 to the fourth. And so this is 4 there, 2 there. And so now what we can actually do is, as we enter this in, 6c4 is 15. And then x squared squared is x to the fourth. That's power to a power, you multiply. And then 2 to the fourth is 16. 15 times 16 is 240. X to the fourth. So again, a little different style of question. If you already have a power within the binomial that you are being asked to expand, you do have to keep in mind, okay, well, if this is x squared and we want an overall x to the fourth, that means you're squaring a squared term. So it's only 2 and 4. It's not, probably the common mistake would be you normally would want a 4 here, 2 there. So that is the one thing you do have to kind of watch for on that. But again, fairly quick set of notes. Day 2 is just wrapping up a little bit that, again, would have been a little bit much for all in one day. But with that, we have completed all material that we are going to cover for the year in pre-calc.